Student, today we will learn the chapter Maxima and Minima. Student, as according to this name, I am going to tell you this chapter, what is the Maxima and Minima. Student, before this chapter you should be learn the chapter increasing functions and decreasing functions, as I have already described in the previous video. Okay, now look here. Here is an axis, x-axis and y-axis. Let here is a curve. And now you can see in this curve what I have seen here, this point and this point. These points are known as peaks. As you know, and these points are known as, and these points and this point is known as valleys. Okay, and student, these 2 points in this graph are peaks and this 2 point is valleys. Okay, student, in this graph internally for a continuous function, this one is your continuous function, right? And what is the continuous functions? You understand better in the previous video. We will compare it with this to this, or with this to this, with this to this, or with this to this. There is a comparing and there is a relative maximum or relative minimum. What you have seen the peaks here, peak in compared to this, okay, and this peak also is compared to this. So these are valleys and these are peaks. So we can say peak on the graph are relative maximum. Okay, peak on the graphs are relative maximum. Why I am using the word here relative? Since it is a compared to other. And you can say valley relative minimum. Okay, this way you can understand this. Now I want to tell you next point. Turning points or stationary points or maxima or minima. Turning points or stationary point maxima and minima. Now students, for this you can go to this graph. Here is a graph. Now in this graph you can see for this point, for this point, and for this point. At x equal to a, let this function is fx, this curve is denoted by this fx. You can see this function is first increase, and at this point again decrease, and for this point it is decreasing here, and here is increasing. For this point here is increasing, then decreasing. For this point first decreasing, then increasing. Okay, here we can say these point, let P and let this Q point. P and Q points are maximum, and let this point are R and S. R and S points are minimum. Okay, now at these 2 points you can see for this value of x less than for this, first is increasing, and for this at this point, after this point it is decreasing. Here is also you can see for this point on the left side it is increasing, and after this point it is decreasing, first increasing then decreasing, first increasing then decreasing. So these are comes to maximum point, and for this 2 point you can see here is decreasing function, again increasing function, decreasing function, again increasing functions. So these are minimum point. What is the increasing and what is the decreasing functions? In the previous video, monotonic, mono, atomicity means increasing, or decreasing, you have already learned. These 2 points or these 2 points are also known as turning or stationary point. Okay, so we can say maximum or minimum points are called turning or stationary points. Okay, so maximum and minimum points are also known as turning or stationary points. You can see the curve is turned at this point to this one, and for this point curve is again turned, increasing to decreasing. So that's why they are known as turning point. Okay, according to our discussion, we have say there are several turning points. Okay, maximum and minimum point values occur alternatively. Maximum point, minimum point, maximum point, minimum point. And it may be possible the minimum point may be greater than the maximum point. let you can see this one. This is the minimum point, but this is greater than this, right? So minimum point may be greater than the maximum point. Now after this I am going to tell you the condition for maxima and minima. Okay student, so condition for maxima and minima in this graph. Now see here, for this at x equal to a, and we take a slightly less than point to left side. Let this is h. H is equal to delta x, and delta x tends towards 0, and therefore this point will be a minus h, and this type of point, let it is h, then x equal to, this point will be a plus h. Now for this function we can say here the value of fa minus h is less than fa less than fa plus h, then it is, you can see here, maxima point, right? And now can see second, maybe you can see here, if you find there f dash a minus h, f dash a and f dash a plus h using differentiation, you can see here is a tangent having acute angle, here is a tangent having 0 parallel to x-axis, therefore here is a slope of this is obtuse angle. So we can say it is positive, it is 0, it is negative, right? For this curve you can see again this one is acute angle tan theta dy by dx is greater than 0, right? And for this parallel to x-axis, so dy by dx equal to 0, right? And for this you can see here obtuse angle, so slope dy by dx equal to tan theta is less than 0. That's why I am saying this one is positive, this one is 0, and this one is negative. So it is clear for maximum point, right? Student understand? The changes of sign is positive, 0, negative. Now you can see if the graph is this way and we want to find at a, here we are taken a minus h, here we are taken a plus h. So you can say fa minus h greater than fa and less than fa plus h, right? Or you can say f dash a minus h fa f dash a plus h. You can see negative, 0, positive, okay, for minimum point, right? So student, this way using calculation method for this one or by differential of first order, we can find the value of where is the stationary point or turning point. Here you can say in the both case turning point is a comma fa, right? So turning point is a comma fa, and fa is maximum value or minimum value, right? So turning point is this fa, and this here fa is minimum value, and in the previous case here fa is maximum value, right? So student, this way we can get the value of turning points. Now again I am going to be writing this. For a maximum point, conditions are dy by dx equal to 0, first condition. Second condition, dy by dx changes the sign from positive to negative, and for a minimum points dy by dx should be equal to 0, and also dy by dx changes sign from negative to positive. Now student, is dy by dx is a condition that is enough? No. Note, dy by dx equal to 0 is not a sufficient condition for maximum or minimum point. Okay, why this is not a sufficient conditions? You can see here is a graph, and at this point dy by dx equal to 0, and dy by dx going from positive to 0 and 0 to again it's going to positive. So you can see here dy by dx is 0, then we can say here point of inflection. So dy by dx being 0 for a functions, it's not necessary conditions for that to find the maximum or minimum value. It may be dy by dx equal to 0, but dy by dx is not changing the sign from left to right. Okay. Now using this, if this is not the signing of the change here, you can say also this way. Okay, negative to 0 to negative, this is also point of inflection. Dy by dx is here also 0, right? So student, now for point of inflection we have seen here tangent is parallel to x-axis and cross the curve. Tangent is parallel to x-axis and also cross the curve, and sign is not changing. So condition is dy by dx equal to 0. It is fa minus h and dash and fa dash fa plus h. You can see that here is a. So it is positive 0 positive, or it may be f dash a minus h, f dash a plus h. It is negative 0 negative, right? For this negative negative, okay, so sign does not change. Sign does not change. Now how we can find this? We understand by higher order derivative. How all this we can understand by higher order derivative, and we will use the all these things by modifications of the second conditions, that is second order derivative. Now since dy by dx is 0 and positive to negative for maximum value, okay, so we can say d2y by dx square is, here we can say positive to 0 and negative, means it is going to negative, okay, so we can say positive to negative, it is loss, so we can say d2y by dx square less than 0 for maximum, okay. Similarly we can see here, since dy by dx is negative 0 positive, hence we can say d2y by dx square negative to positive, it is increasing, okay, so we can say this is greater than 0. Understand? So using higher order, if dy by dx equal to 0, so we can say by taking the sign of d2y by dx square and d2y by dx square either negative or positive, we can say it is maximum or minimum, right? So this is the condition for maximum and this is the condition for minimum. Understand from this curve, negative to positive, it is increasing towards to positive, so therefore it should be greater than 0. Understand? Now again I am going to be point of inflection. Dy by dx equal to 0 and again d2y by dx square is equal to 0. Then we have to find out dqy by dx cube. And we can see here for inflection point or it can see that you can see here for dy by dx equal to 0, it is doesn't change, positive to positive, positive to positive. It means we can see here the function is increasing. Here the function is increasing. Okay, positive to positive, function is increasing. First is change positive to 0, then 0 to positive, and here negative to 0 and 0 to negative. So we can say here is positive to 0 means value is decreasing. Value is decreasing, right? But again here value is increasing. 0 to positive. Now you can see here, if d2y by dx square equal to 0, then dqy by dx is either is positive or negative. If it's positive to 0 means negative, or if it is negative to 0 means positive. So if d3y by dx square is minus or plus, means function is neither maximum or minimum. Here is a point of inflection. Okay, minus or plus. In this case minus, in this case plus, right? So what happened at the last, what we have got the formula, that is first y equal to fx, second we should do f dash x equal to 0, solve for it, find x equal to x1, x2, x3 and so on, and then find f double dash x1 for x1. If may be 0, it may be positive, it may be negative. If it is 0, then find f3 x1, it may be 0, it may be positive, it may be negative. If 0, then again find f4 at x1, it may be 0, it may be positive, it may be negative, and so on. 0 cannot tell you any values. Now for this and for this, positive means minimum and negative means maximum. Again here positive means minimum and negative means maximum, and in this case point of inflection. Okay, and this way we can tell you for d2y by dx square, d4y by dx4 even order. Positive means minimum and negative means maximum. Okay, and for d cube y by dx cube, d5y dx 5 odd order. Positive or negative means point of inflection. Okay, and derivative even or odd will equal to 0. It will not tell you the answers. It is not the sufficient conditions to find your answers, right? So student, this way you can find out the maximum and minimum solutions. In the next we will do some questions according to this, right, to find the application also, maximum and minimum, and practical problems. Thank you for this video. Thank you for watching. Thank you.